Welcome to our channel. Today we're diving into the mind-bending world of physics paradoxes that will leave you questioning reality. These are the cosmic puzzles that keep physicists up at night, staring at the ceiling, wondering about the very fabric of existence. From Schrödinger's cat to time travel conundrums, get ready to have your mind blown. We're about to explore the boundaries of what we think we know about the universe, and trust me, things are about to get really weird. We'll be your guide through these intellectual minefields, so buckle up and prepare to explore the universe's strangest mysteries. Alright, let's start with a classic head-scratcher, Schrödinger's cat. Imagine a cat sealed inside a box. Not just any box though, this one's equipped with a device containing a radioactive atom. Now there's a 50-50 chance that this atom will decay. If it does, it triggers a mechanism, releasing a poison that's fatal to our feline friend. Here's where things get really strange. According to quantum mechanics, until we open the box, the atom exists in a state of superposition. This means it's both decayed and not decayed at the same time. That's right, it's in two states simultaneously. And since the cat's fate is tied to the atom, the cat is also in a superposition, both alive and dead. It's not that we just don't know which state it's in, it's really in both states at once. It's only when we open the box, make an observation, that the superposition collapses, and the cat snaps into one state or the other. Think about that for a second. Our very act of observing forces the universe to choose an outcome. The cat's fate isn't determined until we look inside the box. Now, I know what you're thinking. This is insane. Cats can't be both alive and dead. And you're right, in our everyday macroscopic world things don't work that way. But in the microscopic world of quantum mechanics, things get fuzzy. Particles like our radioactive atom can exist in multiple states simultaneously. It's just that when we scale up to the world of cats and boxes, it seems impossible. Schrödinger's thought experiment wasn't designed to torture cats. It was meant to highlight the strangeness of quantum mechanics. It forces us to confront the limits of our intuition and embrace the bizarre reality of the quantum world. Next up, we're tackling the mind-bending realm of special relativity with the twin paradox. Imagine identical twins. Let's call them Alice and Bob. Alice volunteers for a space mission, hopping aboard a spaceship that can travel at speeds approaching the speed of light. Bob, on the other hand, stays firmly planted on Earth, watching his adventurous sister zoom off into the cosmos. Now here's where Einstein's theory of special relativity throws us for a loop. It tells us that time is not absolute, but relative. As Alice speeds through space, time actually slows down for her relative to Bob back on Earth. This isn't some kind of illusion. It's a fundamental consequence of how the universe works. The faster you travel through space, the slower you travel through time. So Alice zips around the galaxy at near light speed for what feels like a few years to her. But when she returns to Earth, she finds that decades have passed for Bob. He's aged significantly, while Alice is still young and spry. This isn't science fiction, it's a real phenomenon called time dilation. Now you might be thinking, wait a minute, this seems like a one-sided trip. Couldn't Alice argue that Bob is the one who's moving and therefore he should be the younger twin? This is the heart of the paradox. The resolution lies in the fact that Alice doesn't travel at a constant velocity the whole time. She has to accelerate away from Earth, decelerate, turn around, and then repeat the process to return. These changes in velocity break the symmetry, making Alice the twin who experiences less time. The twin paradox isn't just a thought experiment, it's been experimentally verified with atomic clocks flown on high-speed jets. The results show that time really does pass slower for objects in motion, just as Einstein predicted. Hold on tight because we're about to venture into the truly perplexing realm of time travel with the grandfather paradox. Imagine, if you will, that you've invented a time machine. Jealous? You decide to travel back in time to visit your grandfather before he met your grandmother. But here's where things get complicated. What if, while visiting your grandfather, you accidentally caused an accident that led to his untimely demise? Let's say you scared him, and he tripped and fell down the stairs never to recover. Now, if your grandfather died before he met your grandmother, they obviously never had your parent, and you were never born. But if you were never born, how could you have traveled back in time to cause the accident in the first place? This is the essence of the grandfather paradox, a mind-boggling puzzle that arises when we consider the possibility of changing the past. The grandfather paradox challenges our understanding of cause and effect. If we can change the past, we create paradoxes where effects seem to precede their causes. It's a time traveler's nightmare, a tangled web of causality that threatens to unravel the very fabric of reality. So how do we resolve this paradox? There are a few possibilities. One is the Novikov self-consistency principle, which suggests that if time travel is possible, the laws of physics somehow conspire to prevent paradoxes from occurring. Imagine trying to shoot your grandfather, but the gun jams or you trip at the crucial moment. Something always prevents you from altering the past in a way that creates a paradox. Another possibility is the many worlds interpretation of quantum mechanics, which proposes that every time a choice is made, the universe splits into multiple parallel universes, each representing a different outcome. In this view, if you traveled back in time and killed your grandfather, you would simply create a new timeline, a parallel universe where you exist, but your grandfather never met your grandmother in this new reality. The grandfather paradox highlights the mind-bending implications of time travel, forcing us to confront the limits of our understanding of causality and the nature of reality itself. Prepare to have your mind tied in knots as we delve into the bootstrap paradox, a temporal puzzle that will leave you questioning the very nature of cause and effect. Imagine finding a copy of Shakespeare's Hamlet, but it's not just any copy, it's a first edition, perfectly preserved. You decide to travel back in time to Elizabethan England, hoping to meet the bard himself. However, upon arriving in 16th century London, you discover that Shakespeare is struggling to complete his masterpiece. In a moment of inspiration, you show him the copy of Hamlet you brought from the future. Shakespeare, amazed by the play's brilliance, copies it down word for word and publishes it as his own. The play becomes a resounding success, cementing Shakespeare's legacy as a literary genius. But here's the catch. Where did the play originate? You got it from the future, but in that future, Shakespeare claimed to have written it. Did Shakespeare write Hamlet? Or did you bring it back from the future, creating a closed loop where the play's origin is shrouded in a paradox? The bootstrap paradox is a fascinating exploration of causality loops, where an object or information seems to exist without a clear point of origin. It challenges our linear understanding of time, suggesting that cause and effect might not always be as straightforward as we think. The information, in this case Hamlet, exists in a self-created loop, traveling through time without a definitive beginning or end. It's like a cosmic game of hot potato, where the information is tossed back and forth through time, existing without ever truly being created. This paradox forces us to confront the limits of our understanding of cause and effect, suggesting that in the realm of time travel, the lines between past, present, and future might be hopelessly blurred. Finally, we arrive at a paradox that extends beyond the realm of theoretical physics and into the vastness of the cosmos, the Fermi paradox. This one keeps astronomers and philosophers alike staring up at the night sky in wonder. Here's the basic premise. The universe is unimaginably vast, with billions of galaxies, each containing billions of stars. Even if a tiny fraction of those stars have planets and a tiny fraction of those planets harbor life, the sheer scale of the universe suggests that intelligent extraterrestrial civilizations should be out there. Moreover, the universe is billions of years old, which means there's been plenty of time for intelligent life to evolve and potentially develop advanced technology. So, if the universe is teeming with alien civilizations as logic suggests, why haven't we encountered any evidence of their existence? Where are all the aliens? This is the crux of the Fermi paradox, a profound question that challenges our assumptions about the prevalence of life in the universe and our place within it. There are numerous proposed solutions, each more intriguing and thought-provoking than the last. Perhaps advanced civilizations are incredibly rare, with humanity representing a remarkably fortunate fluke in a universe otherwise devoid of intelligent life. Or maybe intelligent life is prone to self-destruction, wiping itself out through technological advancements or environmental disasters before it has a chance to reach out to the cosmos. Another possibility is that alien civilizations are deliberately hiding from us, observing us from a safe distance. Perhaps they see humanity as too primitive or dangerous to interact with, choosing to remain hidden until we've evolved beyond our current state. The Fermi paradox is a stark reminder of the vastness of our ignorance. We've barely scratched the surface of understanding our own planet, let alone the boundless mysteries of the universe. It's a humbling thought that serves as a call to action, inspiring us to continue exploring, searching for answers among the stars. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more mind-blowing content. See you next time. Leave a comment below on which paradox blew your mind the most. These paradoxes are more than just thought experiments. They're windows into the deepest mysteries of the universe. They remind us that the more we learn, the more we realize how much we don't know. So keep questioning, keep exploring, and never stop being curious about the cosmos and our place within it.